So let's go to example 2. I gave you the questions, right, already? 4, 5, and 6 for the first one? Yeah. First of all, I would like you to add to this graph, because it does have asymptotes even though they're not drawn in. I would like you to draw them in and label them at x equals 0 and y equals 0. And maybe you even recognize what graph this is. Can you see that this is the 1 over x graph? They gave it to us in function notation, but you could get this same question in explicit notation. And we'll talk about the explicit notation at the end. But first, let's deal with it in function notation. They said, here's a function, f of x. Could be anything, but we know what it is. And we want to sketch the graph of y plus 4 equals f of 1/2 x plus 1. So first thing, I notice it's in the factored form. That's going to be a thing that I always check. Me personally, I would probably take the time, I'm checking the factored form, which it is, and sometimes when I write things out, I like to make my brackets different sizes. When there's brackets inside of brackets, I think it helps you visually see what goes together. And I would move the 4 to this side. Then I would go through from left to right and label things. There are 3 new numbers there. What does the 1/2 do? What does the plus 1 do? What does the minus 4 do? These first 2 arrows are inside, so they're going to be both horizontal. Does that make sense? This is outside. It's going to be vertical. The 1/2 is a horizontal stretch. And underneath, I'm going to tell myself, I need to multiply my x values by 2. The plus 1 is a horizontal translation. Again, those x's are liars. That's going to go 1 to the left. And it is in factored form, so this is good. And then the minus 4 is a vertical translation. That's going to go 4 down.
Sorry for the interruption. With all grade 11 students who have not had their picture taken, please go to the gymnasium to have that done. So that's all grade 11 students with the last names S through Z, and anyone else that may have not had their picture taken in grade 11, please go to the gym right now to get that done. Thank you.
Now with the reciprocal graph, I know that they labeled 2 and 0.5, and we can use that point, and it would actually work out really nicely. It's not a bad point to use. But generally, you'll use this point 1, 1, and -1, negative. And with a reciprocal graph, those 2 points, 1 in each section, is going to be enough to draw our graph. But in a reciprocal graph, we also have to find out what's going to happen to both of our asymptotes. So we'll do all of our those 2 points, and we'll do our asymptotes, and I'll do that at the end as well. So as far as our points go, since we have both kinds of, we have translations and we have stretches, I'll do 2 sets of arrows. For stretches, I only have the one, x by 2. For translations, I'm going to go 1 to the left and 4 down. And as far as where do these points, x by 2, that's going to change this to 2 and -2. My y's are staying the same. 1 to the left will make this 1 and -3. And 4 down will make this -3 and -5. So I'm going to sketch a new graph here by itself. and I'll do it in purple. I'll have those 2 points. So I have the point 1, 3, and negative 3, negative 5, as my 2 points. Now initially that's really, if those were the only 2 points you did, to draw your graph accurately might feel like, I don't know what to do. Yes, thank you. And you can say that out louder when I make a mental math mistake. Right? Do you see how easy it is to make a mental math mistake? I did that point in the wrong place. So, 1, negative 3, that'll move it down to here. Luckily, so easy to make mental math mistakes. You get excited about doing the next part, and that one I didn't check. When you went to draw your graph, I'll tell you that something would have shown up in that would have made you feel like, I think something went wrong. So, next are asymptotes. Now, since your asymptotes start at 0, does it make sense that multiplying by stuff is not going to affect zeros? The only thing, and you can draw one big arrow here, the only thing that affects asymptotes is if you move things left, right, and up and down. Moving left and right is going to affect the vertical asymptote. So moving left 1 will change this one to x equals minus 1. Moving up and down is going to affect your horizontal asymptote. So moving 4 down is going to change this one to y equals minus 4. And if I go to my graph, and I draw an asymptote at y equals minus 4, and I draw an asymptote at x equals minus 1. This would have been the point that I would have been like, uh-oh, sorry guys, I made a mistake with that 1 point, 1 comma negative 3, I would have noticed right now I made a mistake. Because you see how your asymptotes are, and you see how these 2 purple points are sort of symmetrical and equal distance from where those asymptotes cross. I can now draw my final graph going through those 2 points towards my asymptotes. And our graph is done. Ooh, I might, depending on who is marking the exam, this looks like I'm touching the asymptote there. I might get an E10 error for being sloppy. So take your time. Messy writing is not an excuse for being able to not lose marks. So be careful. Okay. Now, the explicit equation, there we go, so we can see everything. You could have got this same question, but instead of having function notation, this question could have looked like this. They could have still kept the plus 4 on that side, that is perfectly fine, but we recognize that our original graph was 1 over x. If f of x is 1 over x, how do I write f of 1/2 x plus 1? Well, the idea of a function is whatever you plug into the function. If the original function was f of x is 1 over x, f of 2 would be 1 over 2, f of 5 would be 1 over 5, f of k would be 1 over k, f of blank would be 1 over blank. You can do that. That's how functions work. Whatever you throw in goes in where the x is. So if we throw in a 1/2 x plus 1, we would get a 1 over 1/2 x plus 1. So the question is, if you were given the question in explicit form, I think it's harder. I think the explicit form is harder because, first of all, in the explicit form you have to go, what was the original graph? Can you see that this originally was a 1 over x? Look where the x is. What kind of equation was it? Then what's happened? This is all where the X is, so this is all horizontal. That +4, when you move it over, would still be outside and still be vertical. So sometimes in the explicit equations, that's a little bit trickier. I have been waiting, and it's never happened that 7-Eleven has come and given me a free Slurpee for assigning questions 7 and 11 at the same time, and posting on YouTube all that free advertising I've been giving them over the years. I know, it's like, Mr. JR should get a free Slurpee for this. But no, never happened.